Here in part B of the example, we are performing a hypothesis test here to see if the means are different for the two locations of fish. So here's the data that we had again. The requirements for our test are independent random samples from two populations. That is true. And then sample sizes greater than or equal to 30. That is true. Our sample sizes were 100. So N1 and N2 here were 100. So first step in the hypothesis test, null and alternative hypothesis. Start with the alternative. That's what you're trying to show. Trying to show the means are different. So that would be mu1 minus mu2 is not equal to 0, or equivalently, mu1 not equal to mu2. Either one of those is fine. And then if this difference equals 0, then mu1 equals mu2. Select our level of significance that was given to us, alpha is 0.01. Sketch the rejection region, step 3. So in sketching our rejection region, we're using the Z distribution, so we can use the table of rejection regions for common alphas. So that table is right here. So alpha is 0.01. This is a two-tailed test, equal, not equal, so plus and minus 2.575. So two rejection regions here. This is negative 2.575 and positive. Next up, we are computing that test statistic. So this is the formula brought down from up above. Our D0 is equal to 0. So in the numerator, this is just going to be the 145 minus 148. And then we're dividing by that standard deviation. We figured that up above here in the confidence level, or confidence interval example, 0.806. And if you compute this on the calculator, you will get negative 3.72 to 2 decimal places. So that's way out here. So our z-test is negative 3.72. And that's definitely in the rejection region. So step 5, our z-test here is negative 3.72. It is less than negative 2.575. So we reject the null hypothesis. So it's not likely that those two population means are equal. So our conclusion then is that there is sufficient evidence to conclude mean 1 is not equal to mean 2. That's the alternative hypothesis. Remember, your conclusion always refers to the alternative. And so that means that the weight differs by location in practical terms. So that's a complete hypothesis test, classical method. And then they also want us in part C to compute and interpret our p-value. So remember, the p-value is the area past the test statistic. So for us, this is going to be the area past the negative 3.72. But then this is a two-tailed test, so we have to multiply that probability by 2. So this we can go ahead and get with the distribution menu here. So second variables, we're using normal CDF, number 2, negative 10,000 up to negative 3.72. And that is 9.964 times 10 to the negative fifth times 2. So we got to move our decimal place 4 places, so that'll be 3 leading zeros and then 199, so 0002 to 4 decimal places. And then we notice that that is below 0.01, so if we use the p-value method, p is less than alpha, we still reject. And then we can check our work here with stat test 2 sample z-test. Let's go ahead and do that. So stat tests, and then 2 sample t-test, 2 sample z-test right there, number 3. We are using summary stats, make sure that's highlighted. Sigma 1 is 4, sigma 2 is 7, x1 145, sample size 1 100, x2 148, n2 100, and then we are doing a not equal test. And then we hit calculate, and there we see our alternative hypothesis, our test statistic, there's our p-value, same that we got by hand, and then sample sizes and means. So this does confirm what we did by hand.